Welcome all of you. Continuing with the introduction part of the course Environmental Planning and Management. So, in today's class we will see the concept of causal loop diagram, and based on a case study. In this we will see the case study of Yellowstone National Park, where the wolves were introduced and ecological balance was restored. Then the need for environmental planning and management, why it is important to study this course or to know these concepts, along with some case studies. So, before we start with the concept of CLD, that is causal loop diagram, let us look at one case study. Okay. This is a case study about how wolves change rivers, and this is a picture generated by AI. So, early 20th century, Yellowstone National Park, it is one of the biggest national park in the world, it is in US, and in early 20th century, because of this predator control efforts, there were efforts on controlling the predators in this national park, the wolves were eradicated from this park. So, it is not like wolves were never present in the Yellowstone National Park, they were there, but in early 20th century, as a part of predator control effects, wolves were removed. So, what happened? This triggered dramatic ecological shifts. Because of wolves population going down or removed, there were a lot of changes which happened in the ecology or the habitat around Yellowstone National Park. And then when the mistake was realized, the wolves were reintroduced in this park in 1995, which actually initiated a trophic cascade. So, trophic, there are different levels, there are different trophic levels, right, producers, then you have primary consumers, secondary consumers, tertiary consumers. So, this trophic cascade was initiated after reintroducing wolves in 1995, which helped restore the ecosystems and also reshape the landscape. Let us look at how it happened. So, before wolves, what happened? Ecosystem collapsed. Because of the absence of wolves, their chain reaction set up, which severely impacted the entire ecosystem of the Yellowstone National Park. Since there were no wolves, the moose population increased. Moose, or you can call it as elk, or like the big size deers, which feed on like vegetations and grass. So, wolves were not there, so their population increased tremendously, and they started overgrazing. Overgrazing means they started consuming the vegetation across a wide area in that national park, and this led to the loss of vegetation. And because of the loss of vegetation, there were no trees or shrubs or grasses left to control the soil erosion and control the banks of the rivers. So, river erosion took place, and rivers, they ceased to meander. Meander means like one which follows like a snake like zigzag spiral path. Because the vegetation was lost, so rivers started flowing in straight wide channels, and since rivers started flowing straight and in the wide channels, the beaver, these are a very unique type of species, which are also called as like engineers amongst animals, because they are the ones which build dams on the water bodies, water streams, and restricts the flow of water and helps aquatic life in that region. But because of the widened river, straight river, and the loss of vegetation or the loss of trees like willow, the beavers could not get twig for their food, and their population collapsed. So, they could not construct any more dams or like blockages in the water pathway. So, that was before wolves were reintroduced. In 1995, when decision was taken to reintroduce the wolf in the park, they introduced 14 wolves in 95 and almost 17 in 1996. And what happened after that? Once these wolves were reintroduced, it marked a historic conservation moment, obviously, because the whole world was watching like what is going to happen, and it is not like things or results would appear soon or quickly. It took like years, but the effect was visible. So, a positive cascade of ecological recovery was visible. As soon as the wolves returned, the population of moose was controlled. Wolves started eating moose, and moose started to avoid areas where wolves were present. So, at least in those areas where moose started avoided going, the vegetation started to recover, because wolves will not eat the vegetation, wolves would eat moose, but because of wolves fear, moose will try to avoid those areas, and in those areas the vegetation started recovering. Because of the vegetation started recovering, the soil started getting stabilized, soil erosion stopped, and which helped to stabilize the banks of the rivers. Okay. So, when the bank of the rivers stabilized because of the growth of trees and vegetation, and when the rivers stabilized, vegetation recovered, the biodiversity also returned, because when there is enough vegetation, trees, water available, the lots of different species of birds and animals which thrive on that, on such habitat, they would return. So, that was the positive cascade of ecological recovery which happened, which was observed after the wolves were reintroduced. But one interesting thing happened, how rivers actually transformed and stabilized. As I told earlier, like when wolves were not there and because of soil erosion, the rivers were like straightened channels. The one which you are seeing in the picture, it is a meandered one. Okay, it is like zigzag, slopey, snake like, and this straightened channel was because of overgrazing by moose and severe degradation of river banks. There were straight, wide, shallow channels, and because of shallow channels, aquatic life will not stay there for a long time. But after the wolves were introduced, we saw meandering and healthy water bodies. Okay. So, because of wolves controlling moose population, the vegetations recovered, the root stabilization by the willow, aspen trees, they reduced erosion, and because of stable banks and slower water flow, it led to the formation of new ponds, lakes, wetlands and riparian zones, which are like buffer zones to maintain the ecological balance with respect to water and land. So, the lessons for conservation from this case study were: one keystone species. Keystone species is like one important species which is usually at the top of the food chain. It can have a disproportionately large impact on its ecosystem. Okay. So, because they are amongst like the higher level of consumers and a keystone species here in this case study, introducing just those 15-20 wolves had a significantly huge impact on the entire Yellowstone National Park. So, that is remarkable. Then trophic cascades, changes at one trophic level can ripple through the entire food web. It will change the other trophic levels, like here we saw when wolves were not there, these populations increased and vegetation was gone. But when wolves were there, the population was in control and the vegetation regrowed. So, that was a trophic cascade. Third was rewilding. The restoring of natural processes can lead to unexpected and profound ecological recovery. The rewilding is the forest or the national park, it got its biodiversity, it got its birds and animal species back, and it was like sort of rewilded. So, these were the lessons for conservation, and this case study forms a very good example to convey about how a carefully thought decision can help maintain ecological, what we say, ecosystem balance, or it can help ecological recovery. So, when nature's balance is restored, ecosystems heal themselves. That is the learning which can be obtained from this case study, is not it? When wolves were introduced, the rest all things fell in place automatically. We did not do anything with the moose or construction of dam on rivers or construction of trees or protecting any other species. The only thing what was done was introducing one keystone species. So, that was all about this case study. So, let us start with a hypothetical case where there is a forest and the wolves are removed from that forest. If wolves are removed, what will happen to moose density, or moose means deer, a deer like animal which feeds on the trees and vegetation. So, if wolves are removed, the moose density will go higher, it will increase, the plus sign means increase, and if moose density goes down, or sorry, if moose density goes up, the population of moose increases, they will consume more trees and vegetation. So, trees and vegetation will go down. Now, since our problem was how wolves affect global warming, so we are moving in that direction. So, if the number of trees and vegetation drops, the canopy and the CO2 storage both will go down, as shown by the negative sign. Obviously, if we cut the trees or the trees are fallen or consumed by the moose, the green cover in the forest will go down, and that will lead to increase in temperature and more evaporation of water from ponds and water bodies. So, temperature and evaporation, it increased. And because trees act as a natural CO2 reservoir or sink, trees take in CO2 and they give us oxygen. So, with the reduction in the amount of trees, there will be a reduction in the amount of CO2 storage. Now, if CO2 storage is going down, the global warming will increase. Similarly, if canopy is going down and temperature and evaporation is going up, the global warming will increase. And these two are interlinked. Temperature, evaporation and global warming can be a cause and effect for each other. If temperature increases, evaporation increases, global warming will go up. If global warming increases, temperature and evaporation will go up. So, both are having a reinforcing impact on each other. Now, because of increase in temperature and evaporation in the forest area, the chances for forest fires will go high. So, the amount of fire will be increased, the number of fires will be increased. Because of fire, there will be CO2 emissions. Again, it will have a reinforcing effect, an increasing effect on CO2 emissions, and CO2 emissions increase means global warming increased. So, CO2 storage decreasing and CO2 emission increasing will lead to global warming, and that is what completes the loop. And when there is a fire, what is going to get burnt? Trees and vegetation. So, you can see with the increase in fire, the number of trees and vegetation go down. So, this schematic representation of a simple case of wolves affecting global warming, this representation in the form of diagram is called as causal loop diagram. Okay. We will see, like, the definition is in the next slide, but we took a small case study relating wolves to global warming. We can take different case study like wolves affecting the course of rivers or soil erosion changing the aquatic life. There are multiple case studies which can be taken from the same video and different causal loop diagrams could be drawn. So, what exactly is causal loop diagram? It is a diagram which points out the interrelationships among different variables within a system, and it also demonstrates their mutual interdependence or influence through feedback loops. As the name says, causal loop. So, cause and loop, these are the two main terminologies, and often systems are complexes and they have, like, they are not static, they have a dynamic behavior, and if you want to understand the dynamic behavior of this complex system, it can be done by this causal loop diagram, mainly using the feedback loops, and these feedback loops can be either reinforcing or balancing. I will explain this in the next figure. So, let us say if there are more birds, what will happen to population? It will increase. If there are deaths, what will happen to population? It will decrease. But in a real world, birds, the population, deaths, they exist, they are in coexistence. These things happen at the same time or at some other time, but in the same habitat. So, we can represent them in the form of loop. If there are more birds, population will increase, and if there is more population, what will happen to number of birds? They will increase. So, that is what you see, birds increasing population, population increasing birds. So, positive, positive, the reinforced, the loop is reinforcing type of loop. Now, if there is more population, just like there are more birds, there will be more death. If there are more people living, there will be more deaths, and if there are more deaths, the population will go, it will reduce. So, this is not a reinforcing effect. Unlike more birth, more population, more birth, it does not go with the death. More population, more death, that is fine, but more death will not be more population, it will reduce the population, and that is called as balancing loop. So, hope you understood the difference between the two types of loops. One is reinforcing, positive, positive, and balancing, where one is positive and one is negative. So, if you look at this diagram carefully, you can see there are 4 basic elements of any causal loop diagram. One is the variables. What are the variables here? Birth, population, death. So, these are the variables. Links, the arrows connecting these variables are the links. The polarities of the links, either plus or minus, and this positive and negative, it does not represent the value or like quality of the variable, but it represents the magnitude, basically a number, either it increases or it decreases. And final is the fourth one, loop polarities, whether the type of loop is reinforcing or balancing. Often in real world case studies, when it comes to industries and environment, you would experience more number of balancing loops compared to reinforcing loops. That's how our anthropogenic environment is made and it operates. There will be more balancing loops in real world case studies dealing with industries compared to reinforcing loops. So, let us take one more example so that it becomes clear how do you draw a causal loop diagram. So, this is an example for like a area where population is increasing and the amount of space available for landfilling waste is reducing. So, how do we draw a CLD for that case? If there is more population, the total waste in the environment will go on increasing. You can see that with the positive sign. Now, if total waste increases, the collection and disposal can also increase, because we will have more waste available to collect and dispose. Now, look carefully. When we collect and dispose more waste, what will happen to the total waste? It will go down, it will reduce, isn't it? So, what kind of loop is it? Balancing loop. Earlier we had more waste because of more population, so we could do more collection and disposal. But the moment we do more collection and disposal, the amount of total waste in the environment reduced. So, that is why this thing has a positive here and this thing has a negative impact. So, it is a balancing loop kind of thing. Now, when we have more waste collected and available for disposal, it will come at some cost. So, if we do more collection and disposal, it will reduce our revenue, available revenue. For more collection and disposal, available revenue will be reduced. But if we have revenue, we can do more collection and disposal. Again, this is a kind of balancing loop, understood. So, when we had more revenue, we can do more collection and disposal, but the moment we spend that revenue and or the moment we collect and start disposing waste, it will be at the cost of revenue. So, this activity will reduce the revenue. Now, when we have collection and disposal increased, the options for treatment also increase. So, the amount of waste going to landfilling will go high, the amount of waste going to recycling or composting will go higher. So, both are getting like reinforced, but it is not a loop yet. Okay. So, we cannot say it is a reinforcing loop kind of thing, but amongst this, if more and more waste goes to recycling and composting will have a decreasing impact on the landfilling, because that is true, right. If more waste can be recycled, treated or composted, we do not need to put that much waste into the landfilling. So, because of this diversion, the amount of waste going to landfilling can go down. Now, if there is more landfilling and dumping, it means the space available for landfill goes down, it reduces. So, more landfilling or dumping of waste will reduce the space available for landfill, but if there is space available or if there is more space available, we can do more landfilling. Again, this is a kind of balancing loop. More landfilling, less space, more space, more landfilling, understood. Just like that, less population and more birth, more population. Now, if this space is there, that will also lead to total waste increase, because we know that there is enough space for landfill. So, we can have more waste, but and if this available space for landfill, if this is higher, it can generate, it will lead to more total waste in the environment. So, I hope with this example it is clear how to draw causal loop diagram and we can point out the loops. This you can just strike off for a while before making it complicated. I think this sort of covers, and as you can see, most of the loops are balancing loops. The next point is need for environmental planning and management. So, with the concepts of domino effect and causal loop diagram covered, I think now it is time to move towards the need for this course before going to actually study the concepts of planning and management. So, why we need to study environmental planning and management? There are multiple reasons, right. One of them, like as you can see in this picture, what is this? ISO 14001. So, it says certified ISO 14001. Are you aware, like ISO 14000 series, it stands for environmental management system. This ISO 14001 is also a type of EMS, environmental management system, and many products you buy from the market nowadays, they will have this ISO 14000 certification. Not just product, the companies, the corporates, the businesses, the industries, they also get this certification, and it is a voluntary standard, but because of this kind of certification, the customer trust is built, because population, the people are getting aware more about sustainability and environmental concerns and issues in like recently. So, we do look at whether the company is certified, ISO certified or not, and this affects the profit or the name or the brand of that company. So, health, safety and security of people and environment, these are the indicators of any, like say, good country or corporate industry and governance. Any corporate or a governing body, they will be looking at profit for sure, but along with profit, if they look after the health, safety and security of not only their employees, but also the community living around, the environment outside the vicinity of that corporate or industry, I think those are the indicators which will prove that that particular entity is a good entity. Also, for several companies or industries, there is a need to obey certain national and international level environmental laws and standards. So, for that case, this planning and management is important, and most of the environmental issues, they are not purely technical. There are many issues which are like, which have a social, a managing, a administrative angle to it, and that deals or that involves lot of planning and management along with decision making. So, I think it is important if we know these basic concepts of planning and management when it comes to environment, and in this course, in this journey, we would be introduced to the concepts of EIA, which is environmental impact assessment, and LCA, life cycle assessment, because it is these type of tools which will help in further plan of action. Like suppose a company knows, if for example, CPCB, Central Pollution Control Board, if they make some compliance for some industry and they have to follow that. Now, for a particular industry to follow any environmental compliance, they need to do this kind of impact assessment studies to know where they stand at present, and then using the tools of EMS, environmental management system, they can set the goals, the plans, the policies, the approach to attain those targets, and make use of all these concepts to satisfy or to obey legally the compliance set by a legal governing body. Also, then there are some concepts related to corporate social responsibility and sustainable development. So, many companies, almost all the bigger companies, they have to spend some percent of their revenue in the corporate as a part of corporate social responsibility, and with the world moving towards achieving sustainable development goals set by United Nations, and the target is 2030. So, in that case, many companies are looking after the environmental projects where they can contribute money from this CSR fund. So, with all this going in parallel in present world, in the present corporate and industrial sector, I think the knowing or having this know-how of environmental planning and management course and tools is going to be helpful. This will be helpful for people who are looking for environmental consultancy jobs in those kind of companies. So, obviously, each of these concepts we will be looking at it in detail in the subsequent lectures, but today just to show like why is it important or why is it needed, we will go through one case study in India. It is from Reliance, Dhirubhai Ambani, Lakhibag, Amrai. Amrai is a mango orchard, it is in Jamnagar, and I hope you know, like Reliance is the leading or the highest mango exporter in India, and what they did was around near Jamnagar, the land was barren, saline, and it was an industrial land. Reliance they converted that industry, the barren land, into productive green orchard land and cultivated mango over 600 plus acres. And not just one variety, but they cultivated 200 plus mango varieties, including Alfonso and Kesar, which are one of the most expensive mangoes in India, and almost 1.3 lakh trees were planted. So, when they did this, obviously one thing we can see here, they converted a barren land into a green land. So, that was a contribution towards environment, but obviously it would have come at a huge cost. But then there were many elements of sustainability or environmental aspect associated with it. Especially they did rainwater harvesting with 40 million liters annually. They also set up 1 million liter MLD desalination plant for watering these mango orchards. The water which was used was either coming from desalination plant or from the rainwater, like the harvested rainwater. And with this, because they avoided they planted trees, the estimated carbon sequestration was around 1500 tons CO2 per year, greater than 1500 tons per CO2. That is the estimated carbon sequestration, this contribution towards environment. And on the social aspect, they trained 5000 plus local farmers and replicated this model in almost 10 to 12 districts of Gujarat under Reliance Foundation's Agri Outreach program. And when this orchid was started in, I think it started in 1997, but over a period of time, some visual observations were there, like the temperatures in summer in Jamnagar. Gujarat is one of the hot states. The summer temperatures in that region dropped down by 1 to 2 degrees Celsius, and because of increased green cover and canopy, the migratory birds, they came back. The new species have been observed lately, and it has made it like a very good eco-tourist spot also for many tourists. So, that is how that is one case study where a company decides to invest in, let us say, environmental side and convert some barren land into a green orchard. But even though initially it spent money, it bore all the cost to do this transition, ultimately there was a profit angle associated with it, and they could generate revenue, becoming the biggest exporter of mangoes in India. So, that is how. So, when we looked at ecosystem functions and services in the previous lecture, there are many services provided by the ecosystem which we do not give economic value. But if we start giving economic value to those services, it will make us more responsible. When I say us, it includes all the human beings, including industries, corporate, obviously they will take the higher responsibility. But yeah, the moment we start giving or monetizing or giving economic value to the services provided by the ecosystem, the face of the environment or environmental degradation is going to change, going to reduce. So, with this Indian case study, there are some case studies all over the world, like for example, REAP 2050 plan. I think you would be aware of London 2012 Olympics, where sustainability and reduction in amount of waste was emphasized a lot, and all the athletes were asked to travel by public transport or electric vehicles, and biodiversity preservation was also a prime concern when the huge tents and the running tracks and courses were built. Then ISO 14001, it is an environmental management system, it is an international standard, though voluntary, it is very much important to show that these particular companies they care for the environment and they care for people's view. So, that way it is important. In Panama Canal expansion project, they did a comprehensive impact assessment for expansion of the canal and EMP's environmental management plan. So, all these big case studies all over the world, they prepared this 100, 200, 300 page document called as environment management plan and successfully implemented it, because all these events have happened now, okay, and they were successfully implemented. So, these are some case studies which you can go through, the notes will be provided in the lecture slides. So, I think I will stop here. So, before closing the lecture, let us quickly revise what we covered here so far. So, the first thing was causal loop diagram, which has basically 4 elements, and it shows the interrelationship between different components of the environment, and those 4 elements were the variables, the links, polarities of the links and the polarities of the loop, whether it is the balancing or reinforcing. Then we saw the example of wolves as well as the waste management and landfill to know how to draw a causal loop diagram for a given case study. Then we discussed about the need for studying this environmental planning and management, since health, safety, security of people and planet both are important. It is important to go beyond economics and consider the services of ecosystem important, and if we give monetary value to that, we can have this successful EMP case studies, or the one which we studied about Reliance case study in India about mango orchard, where they turned this barren saline land into a green orchard by spending money initially, but then after successfully implementing and sustainably running it for long time, they are able to derive profits also from that. It is a very good business model for Reliance, and it is also good for their brand, where they have become the biggest mango exporter in India. So, with this I will stop here. Thank you so much.